Alright guys, welcome to week 2 of the AI journey, and today is actually a really important day because we're finally going to actually start looking into probably like the more relevant machine learning concepts today. And honestly, today I was meant to make my personal portfolio website, but I just felt like I wasn't impressed with the level of knowledge I had and the level of skills I have in terms of how far I've gotten. So I was kind of pissed last week, and I was like, you know what, I'm not going to take any more breaks. I'm just going to speed up. I'm going to be doing like probably double the work now. I'm going to really try and get further because I feel like I want my skills in Python and my skills in actually coding to just be way higher. Oh, for those that don't know me, if my name is Tochi and I'm an electronics engineering student, but I'm basically trying to switch, or I'm looking towards getting a career in AI engineering, so that's why I'm doing all of this. But yeah, it's kind of just annoying because I'm not impressed with how far I've gotten, but we'll see. I'm really going to lock in today. Right now it's 4 a.m. We're back with the usual time. We're going to be doing 4 hours to 5 hours this morning, so we'll end at like 10 a.m. And yeah, we're just going to see how far we get. Today we're getting into PyTorch. It's my first time using PyTorch. Um, but apparently, like, this is the best thing to use for this sort of stuff. And we're basically going to be setting up PyTorch and getting the data for the models we'll be making. But it's actually really interesting because this week we're going to be making an MNIST classifier. So it's basically going to be able to identify handwritten images. So you have if you write a 2 in a weird way, you write a 3 in a shitty way, you can actually detect that, oh, this is 3 and this is 2 and stuff like that. So that's quite cool. We're going to be looking into that. But yeah, I'm just going to lock in right now, go to do a quick 4 hours, and I'll see you guys after that. Alright guys, it's 10 o'clock. We've just done 5 hours of the first day. I've just ticked off. Honestly, today was really good. We learned a lot of stuff. I learned a lot of stuff. I watched some videos on tensors. Tensors is obviously, everyone knows, it's like the fundamentals, right? And even just being able to differentiate between numpy arrays and tensors and why we use tensors is such a big part of understanding this stuff. But I watched this video by StatQuest on tensors. Watched the video on datasets and the data loader. This is a really good video because you need to know how data loaders work. And yeah, ChatGPT gave me the task for today: set up the environment, all the simple stuff. But if I go to the actual code here, really simple. We got the PyTorch. Imported the torch library. Here we're just playing with some tensors really quickly. Weren't doing much. But as you can see here, we have some tensors. We printed out the shapes and the different sizes and all the technical stuff of the tensors, just to understand how the tensors work. There are also some good operations, really popular ones here, like matrix multiplication. I never even knew the symbol for matrix multiplication was at. So yeah, that's all here, just basics. Here's where we got into importing the torch vision library. But basically, the whole point of this week is that we're making an MNIST classifier. So we're trying to classify handwritten digits, for example, like these, into their respective numbers, which are the labels, right? So we want our model to be able to accurately predict what number this is meant to be. And that's the whole point of this week, right? So today we're just setting up, like I was saying before. And yeah, we have 60,000 images to train our model with. And we're using 10,000 of them to test, which is a good ratio, 20%, right? This is just to visualize some of the images, just so I can get a feel for what I'm working with. They're all here. Checking the tensor shape, that's normal. So this just means that number one here means it's like grayscale, so it has no color. If it was free, it would be RGB, but it's just black and white. 28 by 28 means the pixel amount of pixels, right? So just 28 by 28 pixels, and that's all that data is for. And then the data loader is really important because this is basically what we use to batch our data. So we have 60,000 images, right? But we want to batch them into groups of 64 images, and that's the whole point of the data loader. So as you can see here, we're basically printing. So we've made two data loaders, one for the train data and one for the test data, right? And here we're just printing some of them. As you can see here, 64 images in one batch. Same thing, 28 by 28 pixels. And the amount of labels is the amount of numbers we have in a batch, which is like the answer. So it'll be 1 to 9, any of those numbers as the correct label. But there'll be 64 of them in a batch because there's 64 images, right? And yeah, that's pretty much it. Like, that's the end of it. We were just kind of displaying and seeing what we're working with, more setting up the structure for the next few days. And yeah, so now I'm done. I'm just going to head to the gym real quick, do a quick workout, and then we're going to end the day. And we'll look at day 2. Day 2 is we're actually building stuff, you know. Today was good because I learned a lot of stuff, but day 2 will be better. So I'll see you guys at the gym. Okay guys, we're back from the gym. As you can see, for the rest of the day I think I'm just going to do a bit more Python later on in the day, and I'm just going to work on my internship stuff. That is with Python anyways, my digital design internship. But yeah, I'll see you guys tomorrow, day 2. And yeah, stay on the grind, boys. Stay on the grind. Yo, what's up guys? Welcome to day 2 of week 2, and today we're going to be building a multi-layer perceptron to accurately classify the handwritten digits in our MNIST library. So basically yesterday, if you didn't know, we set up PyTorch and we got all the handwritten digits from the MNIST database, whatever it's called. And basically today we're going to be building a blueprint for our model. We're going to basically figure out what loss function we're going to use, what optimizer we're going to use for this multi-layer perceptron, and we're going to try and build that all today so that tomorrow we can start training it on the data we have, right? I woke up a bit late, so it's currently 6 o'clock. We'll do 4 hours to 5 hours, probably end at 11 today, and then I'll show you guys how far I've gotten. Might definitely go to the gym today, do some other stuff, and yeah, that's pretty much it. It'll be a pretty typical day. And yeah, so I'll see you guys in 4 hours. Yo, what's up guys? I'm finally done with the study session. Today was quite chill, to be fair. All we did was pretty much just learn concepts. We didn't really do that much of coding, I would say. But I just watched some videos. I'll show you guys the videos I watched. I was watching this video on this sequential method in the PyTorch library. It's really important for basically building up the blueprint for your multi-layer perceptron. When I look into cross entropy was what I had to look into. I watched the video on this because this is like the best way for classifying stuff, as the best loss method for classification. So I had to watch a video on that. Optimization techniques, I watched a video on this. We chose to use Adam because Adam came out to be the best, but we could have used stochastic gradient descent, but I didn't use that. But yeah, when we look at the code, I didn't really do much, just imported some new modules, as you can see here. This is the main blueprint for the model. So as you can see here, it's like the sequential flow of the layers. So first the image gets flattened, so it's 28 by 28 pixels, right? It gets flattened to a one-dimensional array, and then this linear function basically converts it to less neurons, so it gets to 128, right? And it keeps converging to 64 all the way to 10 as the output. So basically, this is the main connection between this is where like the weights and biases get optimized to bring out smaller outputs. And the 10 at the end is basically all of the digits from 0 to 9. That's 10 digits. And that's basically what the model has to predict on. So yeah, as you can see here right now, it has 109,000 parameters. That's not that much. That's tiny. That's tiny compared to like the actual LLMs and stuff we use today, right? And it's only like 0.40 megabytes. That's so small. So what was that? It's like 42 kilobytes. I think so. I don't know. But yeah, so today was pretty chill. I didn't really do much. It's more of just learning. I also looked through some other stuff on the PyTorch website. Just some extra stuff down here. Should be. Yeah, just some extra. I just looked through some other stuff, but it wasn't really important. It wasn't really related. There's also this function is really good. It's auto gradient function. It helps you do backpropagation automatically. So that's also really good. But yeah, that's pretty much it. So we're done for today. Let's tick up what we've done. I made the blueprint for the model, and we printed out a summary, as you can see here. So right now, I feel a bit tired today. I don't know why. Probably because I slept 6 hours, so I kind of, yeah, it's my fault. But I'm going to head to the gym. We're going to do a quick session at the gym, and then we're going to come back and get ready for my meeting with my company. So I'll see you guys in a bit. Alright, so we came back from the gym. Just did some internship work for a couple of hours. So finally done. So we're done with day 2. That's pretty much it for today. I'll catch you guys in day 3. Stay locked in, keep working hard, and you'll make it.